What if you could modify a mounted FastMCP service on the fly and see those changes instantly reflected in your main application? You'll see how dynamic mounting creates a live link between servers, where tools added after mounting become immediately available through the parent server. We'll demonstrate this by adding a new tool to a mounted service, then calling it through the main application, all without restarting anything.
Import Asyncio. From FastMCP, import FastMCP, client. Hash define subserver. Dynamic MCP equals FastMCP. Name equals dynamic service. At dynamic MCP, tool. Def initial tool. Initial tool demonstration. Return, initial tool exists. Hash mount subserver, synchronous operation. Main MCP equals FastMCP. Name equals main app live. Main MCP. Mount dynamic MCP, prefix equals dynamic. Hash add a tool after mounting. It will be accessible through main MCP. At dynamic MCP, tool. Def added later. Tool added after mounting. Return, tool added dynamically. Hash testing access to mounted tools. Async def test dynamic mount. Tools equals await main MCP. Get tools. Print available tools. List tools keys. Hash shows dynamic initial tool. Dynamic added later. Async with client. Main MCP as client. Result equals await client. Call tool. Dynamic added later. Print result. Result data. Hash shows tool added dynamically. If name equals main. Asyncio. Run test dynamic mount.
This demonstrates dynamic server composition through live mounting, a pattern that enables runtime modularity in FastMCP applications. Unlike static composition, where components are copied once, mounting creates a live link between servers, allowing changes in the subserver to immediately reflect in the parent server. The distinctive aspect is its dynamic nature, where tools and resources can be added or modified after mounting, with all changes automatically propagated to the parent server. The pattern works by establishing a delegation relationship rather than copying components. When a request comes to the parent server for a prefixed component, it dynamically routes that request to the mounted subserver at runtime. This creates a hierarchical system where the parent server acts as a facade, while subservers maintain their own state and lifecycle. The prefix system ensures clean namespacing, preventing collisions between components from different servers. This approach solves the problem of maintaining modularity in growing applications without sacrificing runtime flexibility. It's particularly valuable when you need to hot reload functionality, support plugin architectures, or enable team collaboration where different components evolve independently. The trade-off is slightly higher latency compared to static composition, as requests must be delegated at runtime, but the benefit is true dynamic modularity where changes propagate instantly without server restarts. Let's break it down.
Import Asyncio. From FastMCP, import FastMCP, client.
Imports Asyncio for async function support and FastMCP with its client class for creating AI callable tools and connecting to MCP servers. This is the foundation for building modular async-capable tool systems that expose Python functions to AI models.
Hash define subserver. Dynamic MCP equals FastMCP. Name equals dynamic service.
This initializes a FastMCP subserver instance named dynamic service. It creates an isolated tool namespace that can later be mounted into a parent server, enabling modular service composition. The name parameter identifies this subserver in the mounted hierarchy.
At dynamic MCP, tool. Def initial tool. Initial tool demonstration. Return, initial tool exists.
This defines the first AA callable tool in the dynamic MCP subserver. The decorator at dynamic MCP tool exposes this function to the main server, with the docstring serving as the tool's description and the return value as its output schema. This establishes the pattern for adding tools before or after mounting the subserver.
Hash mount subserver, synchronous operation. Main MCP equals FastMCP. Name equals main app live. Main MCP. Mount dynamic MCP. Prefix equals dynamic.
This creates the main FastMCP server instance and mounts the dynamic subserver under the dynamic prefix. The mount operation merges all tools from dynamic MCP into main MCP while namespacing them, enabling hierarchical tool organization without manual registration. This pattern allows dynamic addition of tools even after mounting, as demonstrated in the next segment.
Hash add a tool after mounting. It will be accessible through main MCP. At dynamic MCP, tool. Def added later. Tool added after mounting. Return, tool added dynamically.
This demonstrates FastMCP's dynamic tool registration. Tools added to a mounted subserver remain accessible through the parent server, enabling runtime extension without restarting the main application. The pattern supports hot reloading capabilities in production systems.
Hash testing access to mounted tools. Async def test dynamic mount. Tools equals await main MCP. Get tools. Print available tools. List tools keys. Hash shows dynamic initial tool. Dynamic added later.
This verifies dynamic tool mounting by listing all available tools through the main server. The output confirms both pre-mount and post-mount tools are accessible under the dynamic prefix, proving the mount operation preserves dynamic updates. This is the standard validation pattern for testing MCP server composition.
Async with client. Main MCP as client. Result equals await client. Call tool. Dynamic added later.
This uses FastMCP's Client Context Manager to establish a connection and automatically handle cleanup. The call tool method executes the mounted tool by name, demonstrating how dynamically added tools remain accessible through the main server. Context Manager pattern ensures no lingering connections or resource leaks.
If name equals main. Asyncio. Run test dynamic mount.
Standard Python entry point guard ensures test dynamic mount only executes when run directly, not when imported as a module. Asyncio run boots the async event loop to execute our test function, demonstrating the dynamic tool mounting behavior. Dynamic server composition. FastMCP's mount system enables runtime server composition, where tools can be added to subservers after mounting and remain accessible through the parent server. The prefix parameter automatically namespaces all mounted tools, creating a hierarchical resource structure without manual naming. This pattern eliminates the need for complex dependency injection by treating servers as modular components.
The server that disappears into another becomes everywhere at once.